Okay, so one more thing that I want to ask you is that I mean it's a bit related to what we are talking about. Uh, how to learn, what problems to work on. I mean, this is something that a lot of people struggle with, especially the young people. That how to choose good problems to work on. Do you think that one inevitably learns this as you get older, you get more experienced, or is this something that you can learn even at a younger stage?
So my advice is that, so academic career is something that takes sometimes a toll personally. You gotta move countries often. It can be difficult in many ways. So to me, my opinion, is only worth it if whatever you're working on is interesting, it's fun, and it's something you care about. So what I would advise is that people try to look for problems they find interesting. Okay, whatever it is, but it's a problem you find interesting, you want to think about. Now, I also think it's very, very good because they are intrinsically interesting to think about the big problems. Okay, so I think
Hmm.
there's this quote to Nima, which is like one should think about the cosmological constant 15 minutes every day. Okay, so I don't, I unfortunately I cannot say I think about it 15 minutes every day. I maybe pack it up in 1 hour at the end of the week or something. But I really try to. You try. It's good to stop and think about big problems. Okay,
Hmm.
even if you're a student, because we honestly, as a community, we oftentimes have no clue. Okay? If we knew exactly what to do to solve the hierarchy problem, cosmological hierarchy problem, electroweak hierarchy problem, the big problems in string theory and in the framework, people would have done so already. There's proposals, there's many proposals which are appealing in many ways, but we really have no idea what is the actual solution to the big problems. It can come from you, it can come from anybody. Okay? It might
Hmm.
just be that you need a different perspective and maybe you get it. Even if not, that's what it's really about. Okay, we are really trying to push frontiers of knowledge, and to push frontiers of knowledge, you have to be ambitious. You have to try to think about big problems. Maybe it's high temperature superconductivity. Doesn't have to be like like cosmology. Those are the ones that I like more, like cosmology and stuff. But whatever, try to think about the big problem. Maybe you'll solve it, maybe you won't, but you will learn a lot about it just by because you will think and say, oh, maybe I would do it like this and like that. Has anybody done anything like that? You read a paper, and
Hmm.
the thing is that you're motivated, that you're enjoying that. That's very, very important. Okay. So whatever you do, try to work on things that you find interesting. Now, of course, you cannot spend your whole day just thinking about the cosmological constant problem. You need to find also concrete projects, and that's another skill that you will develop over time, which is find
Yes.
projects in the intersection of interesting and
Doable.
cool. But
Yes.
my advice is, if you went through the work of understanding something and you understood it, okay, it might be worth, putting together like a little short note. It's like not every paper that is written has to be, the Principia Mathematica. Okay. So it can also be, so maybe you write something that you put together things that are known, let's say. So you start thinking about something, and by the time of that you're done, you realize that all the pieces for that sort of were already in the literature. Still put a note. You made an effort, you understood it, it's going to be good for you. And maybe your unique way, because that's going to be unique, your unique way of putting together things might be also helpful to others. And I know many such instances. Okay.
I see.
So that can also be very, very helpful.
So, um, if I understood correctly, you're saying that if you just start to put together things that are known in the literature, that process may give you ideas for projects. Is that
It
what you're
may
saying?
it may give you ideas for projects, but also like I don't know, for instance, like uh, I cannot come up with a good analogy right now, but um, sometimes you start learning about a problem and maybe you figure parts of it yourself, and then once you have figured it out, it's much easier to find things in the literature, and you find that, oh, so I did this calculation, but this was already done in this guy in the 60s, but for a different problem,
Mm-hmm.
and somebody else did this, but for a different story. So in some sense, you could say, oh, but everything is already in the literature. Sure, but you putting it together in a simple package, clear paper, you should try to write clear papers, can be
Mm-hmm.
very, very helpful for the community. And sometimes presenting old things in new languages can lead to massive progress. An example of that is this idea of generalized symmetries.
Mm-hmm.
All the
Yes.
story of symmetries, thinking about the generalized higher form symmetries as topological operators and the like. Um, you can read about most of that in papers of Toft, in some sense. Okay,
Yes.
Wilson loops, so on and so forth. Now, The 2014 paper of Gayoto Kapustin, Cyber Willett, which
Hmm.
introduced these generalized symmetries, it had a few new results, but most of it, in some sense, was like a relabeling, a repackaging, a new language to talk about symmetry. It triggered an explosion, okay?
Yes.
Even though most of the results were, in some sense, in the literature.
Yes.
So sometimes just presenting things in a new way can be extremely helpful. So
Do you think?
what I'm saying this is that the reason why I'm saying this is that oftentimes you find like younger researchers that they made a lot of effort, they figure out some problem, and by the time they're
Mhm.
done, they don't think it's that interesting. They say, well, if you put together A, B, and C, it's already in the literature and stuff. So I just want to encourage to anybody like that who might be listening to us to wrap up the thing, put it in an archive. The worst that can happen is that, you know, some people think, yeah, I already knew this. I guarantee to you there will be readers that didn't know it.
Yeah, of course. I think that's very true. So there's one question. I think I kind of know the answer to that question, but I'm asking this question because I know that some young people have this kind of question. So this example that you gave, the general asymmetry paper example, do you think that if that paper was written by a young researcher, people would have taken it seriously?
Hmm. I think the I think it would have been harder,
Yes.
in the sense, or it would have taken longer,
Okay.
uh, and it would have been okay. I think yes, I think it could have, but it
Okay.
is not certain. So, but that's okay. Look, the thing is that the sociology of it, we are not. So, what it certainly would have happened, it might not have become such a widespread thing. But I think
Hmm.
a lot of people, or some people in the community, a good chunk of them would have learned about the paper and would have found it very interesting. And I know examples of papers that have done that, maybe uh,
Okay.
for small communities. So the thing is that, you know, when the problem is really that people time is finite. There's a lot of papers in archive every day.
Hmm.
So, if there's a paper by a very well-known researcher that people respect, you know for sure that one contains very good non-trivial stuff.
Hmm.
Okay? So you're gonna stop and read it a little bit, or just look at the abstract, maybe if you're very busy. If the same paper is written by a younger researcher that you don't know, you might erroneously filter that one out because you don't know the person and you have to go to a meeting. That's the only reason.
Yes.
If you had infinite time, you would go through all the papers and you would say, "Oh, this is an amazing paper." Okay? So what that
Hmm.
means is that if the same paper is written by more junior researchers, it might take longer for it to become well known. It become more like word of mouth. So you will go to conference and say, "Oh, did you see the paper of such and such? That's a very nice language." Yeah, I think if some other people would have written that paper, it would have reached, I think, you know, order of magnitude the same impact. I think it would have
Hmm.
taken longer.
Longer. I
Yeah,
agree, actually. I actually agree with your answer, and this is the answer that I had in my mind. But this is a discussion that I had with some of my younger colleagues, and they were having these kind of reservations. That's why I asked the question.
but I think that's the wrong framing. If you think
Hmm.
that the reason why you should put out a paper is because you think it's interesting,
Yes, I agree. I
not
agree.
because what other people might think or might not. You don't control that. You don't know what that is.
Hmm.
So if you did hard work, also I'm not encouraging people to just put out whatever comes to their brains, write the paper in 5 minutes, and go for a beer. I'm
Yes,
not saying that. But if you
sure.
spend time on a problem, you thought it through, and you go through the extra effort of putting it together in a readable, reasonable way. Okay,
Hmm.
why not? If somebody doesn't care about it or they're not interested, that's their business.
Sure.
It should be out
Okay,
there because you are interested in it.
I agree. So if you like this video, give it a thumbs up and consider subscribing. And the YouTube algorithm thinks that you will also like this video.